In the last video, we introduced the annuity immediate with P3 payments and how we can utilize what we already know to derive the present value and the accumulated value. Now in this video, we solve some examples from the textbook to use these formulas we just derived. The first one is example. Let's do example 4.13. So that's on page 108. So what we want to do is find the present value at time 0, of course, at time 0 of payment of $30 at the end of each quarter for 8 years. And what's given is the nominal interest rate is 5%, and the frequency is convertible monthly. So that's an interesting question because the unit period is per quarter, right? As we can easily see from here. But the nominal interest rate you are given is actually convertible monthly, right? So let's. So we have a total of 8 years. In each year, the payment is made at the end of each quarter. So 1, 2, 3, 4. There are 4 quarters in a year, and at the end of each quarter, we receive $30. So this is slightly different from the third half, because third half would say we will receive $120 per year. So this is the same, equivalent to $100 per year. By the way, we always assume equal installments, so equal payments, at the end of each quarter. So $120 per year means $30 per quarter. Okay, so well, then everything works exactly as what we just proved, right, or what we just derived. So it would be the total number of the per year, right? Because it's based on per year. Previously, when we derived this formula, there's $1 per year. Now it's $120 per year. So at least in terms of notation, we would have 120 times A. On top, it would be the number of payments, so it's P. So here is quarter, so there are 4 payments a year. And at the bottom, it would be N. N is 8. So that would be the notation, right? According to what we introduced down here, okay? But you can introduce an alternative definition. From here, what do we need? If you want to apply this formula, we would need to know V and IP, right? So that is at least one of the direction we can work with. So let's write it down. Okay, so 1 is 4, not 4, 8 divided by I of 4. Okay, so we want to know what is V, what is I upper 4. But what's given? We know this is 5%. What is 5%? This is the meaning of the last sentence. The nominal interest rate is 5% convertible monthly. Monthly means, in this particular case, P is 12. Right? There are 12 compounding payments in 1 year. And that's why I write I upper 12. So here's 12, right, equals 5. There's a mismatch, right? What we are given is I12, but what we want to know is I4, okay? How can we convert from one to the other? But first, we can use this. meaning what I have is the accumulation for 1 month. Raised to the power of 12 will give me 1 year. That would be 1 plus I. I can apply the same thing. Right? So from here, not only I get I, but also get the I4. Right? So first of all, V equals 1 plus I to negative 1. So it would be 1 plus 5% divided by 12 to negative 12. So I'm able to get the first quantity I want. Then I would want to know my I4. So my I4 would be, of course, then I need to raise the fraction power 1 over 4. Right? So once I do 1 over 4, I would have I4 equals the entire thing. Well, it's 5%. So let me write 5%. 5% divided by 12. Now it would be 12 divided by 4, so it's 3. So its meaning, it has its own meaning, right? Because inside the bracket is the accumulation for 1 month. 1 quarter has 3 months. So that's why I raised to the power of third, right? Go to the 3. It's the end of the 3 months at the end of 1 quarter, minus 1 times by 4. Right? So that's what I have. Okay. You can do the calculation. Once we have all the numbers, we can plug in. Of course, here I missed the 120. So 120 times that. Okay, we know we know I upper 4. Then we just plug into that formula to get the result. But of course, we can simply treat this as a standard annuity, right? We don't need to use this new notation, meaning I don't need to use that new notation. I can simply analyze this as once I know I upper 4, I can get the effective, right? What is my number? So if you do your computation, it's about 1.2552%. So this is the effective interest rate per quarter. Okay, then I apply the standard notation of level annuity. Each size is 30 instead of 120 because I'm looking at each payment. I'm doing a standard annuity immediate, but I would want to know how many payments. There are 4 payments each year, and I have a total of 8 years, meaning I would have 32 payments. Now my interest rate would be 1.2552%. Right? This I can easily calculate from my financial calculator, and then I just need to times by 30. That's why here the 2 things are important. First, you need to know how to convert to the effective interest rate you want. For instance, if you apply this result, you will need to know the effective interest rate per quarter. Once you know that, you will need to know the number of payments. Usually that's easy. That's just the n times p. And then you need to know the size of each. So this is the size of each payment. Right? In the previous formula, 120. So in this case, 120 is the total payment per year. And this per year is fixed. It doesn't matter whether you have quarterly payment or monthly payment. It's always per year. It's the total amount of payment per year. So that's why I will need to do 30 times by 4 to get 120 in order to apply that formula. That's why personally I don't like this. So in my own opinion, this is not not something that I would prefer, at least. What I like is this, because it uses the old concept. I don't need anything new. I just need to convert the new problem into the old framework I am very, very familiar with. That's why, I have mentioned many times that in this course, the only thing you actually need to learn is annuity immediate. Everything else is consequence based on it, right? And the annuity immediate is based on geometric sequence. So the bottom line is geometric sequence, and then we study annuity immediate. Everything else will be a natural corollaries of what we study from annuity immediate. So from here, you can easily get the result. Let's do the next example, which happens to be example 4.14. So now what do we have? We still want to know the present value, okay? So we still want to know the present value. So we found PV of payments of $480 at the end of each quarter. So it's still each quarter for 8 years. So everything is the same, but what do we know is I is, okay, now I equals, I don't want it to be capitalized. I is 8%, 6%. So of course, I is going to be the effective annual interest rate. So first of all, we need to express everything into annually quarterly, and every other year. So that's actually by annual. Part A, what do we have? It's doing notation. So let's work out this. So now I have what I have. I have the size of each payment is $480. So I need to convert it to per year. What I will receive each year, so it will be times by 4. So I will get 9. So that's the total amount, annual payment. So that is the annual payment. Okay, and then I just need to give the notation. It would be, so on top I would need to put 4 because it's quarterly payment. At the bottom I will put 8. That's because the total number of years is 8. So that's why, for each notation you really need to understand, because once we write this, that is to, so let me write it again. So here what we assume is $1 per year, okay, and paid P times. Okay, for n years. So that is the notation. So here n is actually years in the unit of years, that is fixed, and P is the number of payments in each year. That's why here since it's quarterly, so I know it's 4. Since it's for 8 years, that is why I put 8. But if you want to apply the standard annuity immediate, the notation would be different, right? Because in that case, so of course I haven't put anything down here yet. That would be the, well, if you want, you can put the effective interest rate I if you want. Okay, what I can equate is 480. So that is the size of each payment. Okay, then I need to figure out how many payments. Of course, and then I will need to know the unit interest rate. right? So it's the effective interest rate per quarter. So it will be the nominal divided by the number of divided by P, right? So for 480, I missed the zero. So that's the part one. Let's see, what is the next? So you can try to convert it into, here they just want to denote into the different notation. So I already did it for part one because this is based on the annual case. If I want to study it at, this is one, the on the right hand side is two. What's interesting is you can actually match to anything you want. The last one is every other year, meaning there's one every 2 years. That's interesting. That's because you can actually do this. Let me show you the last case. Okay, how can I convert now? I originally I have $480 per year. Okay, but now I want my unit period to be 2 years. Right? Before we actually cut 1 year into many parts. Now what we do is we actually need to make 2 years together as one unit. Okay, and then the first thing we need to figure out is what would be the payment per unit period, right? Then it would be it would be, we know 1 year is this amount, right? Now it's 2 years, so the amount would be this times by 2. Okay, and what else we need? We need the number of years to be from 8 to 4, because here it's 8 years. Let me put the unit. Otherwise, it's confusing from 8 to 4. 8 years is 4. What would be the word for it? It's 4 2-year period. So it's a little awkward because now each period stands for 2 years, right? So 8 years means 4 2-year periods, right? Because one period equals 2 years, right? Okay. Then what I need is I know this is still 4, and no, not it's what would be the answer? So I already figured out the payment. I already know the number of periods, and I still need to know the effective interest rate, but now it's for 2 years. Right. So now what I do is so this is my accumulation factor for 2 years or for one period. This equals. So now the interesting thing is 1/2. Right? That is exactly the notation according to our convention, right? Because we usually say is with P, they are P payments per year, okay? But now it's actually every 2 years you will receive one payment. So over 1 year you will get half payment. So that's why that's the awkward thing is here I have to actually introduce half. So from there I get I half would be because it is 6% for I minus 1 times 2, right? So I get the effective interest rate. So now what I would have would be introduce the notation. This is the amount I pay, or the amount I receive in each period, although here one period stands for 2 years. Okay, then I have A down here. On top, I would have to put 8. The reason it's simple, that's because I need to count the number of payments in one period. In this case, everything is for 1 year, right? So this is the payment per year, because year is the period, okay? This 4 is the number of payments per year. And finally, what is here? This I is the effective interest rate per year. Right? Year is the unit I use in the first case. Now, 2 years is the unit now. So that's why this is the payment per every 2 years, right? And 8 is the number of payments per 2 years, because there are 4 payments per year. That's going to be 8 payments per 2 years, right? And finally, this would be the number of years. Where do I put? So let me put it here. This 8 is the number of years. In other words, it will be the number of unit periods, right? So that's why here I would have 4. 8 years means there are 4 periods, right? And finally, I will put down the effective interest rate per 2 years. It would be I half, right? That would be the notation. So it's the last one is a little awkward, but if you understand the last one, you should understand all the notations we introduced. The last example we do is it's obviously the future or the accumulated value. So let me give you the example. That's 4.15. So we want to find the accumulated value at 10 years of payments of 200 at the end of every other month for 10 years. So what we know is the nominal interest rate is 12%. So when we quote nominal interest rate is always per year, but here it's convertible quarterly. So meaning it's IR per 4. So things are, again, this is similar to what we did, right? The frequency of payment is not the same as the frequency we have for the nominal interest rate. Here, it's at the end of every other month. So what we have is unit period equals 2 months, right? But what we have from the nominal interest rate is I R per 4 equals 12, right? Meaning it corresponds to 4 payments a year. But right now, what do we want? What we want is actually I R per 6, because the unit period is 2 months. So there are six periods in a year. Okay. There are a few things you can do, right? So first, we can just apply the new notation. Under the new notation, we would want to know, for instance, the new notation. Actually, the default setup is this guy. Right? We assume we use the annual notation to denote everything. Then our first job is to convert the amount into amount per year, 200 every 2 months. So there are 2 months a year. So every year I'm supposed to get $1,200. Ignore discounting or accumulating. And then my notation would be this. So on top would be the compounding frequency per unit, not per unit, per year, because here we assume we take annual notation. right, corresponding to I in the previous example. Since we choose 1 year, so there are 6 payments a year, and I need to count how many years. So it would be 10 years. So here I should put the effective interest rate, but if, well, since there's only one frequency we pick here, so we don't need to write if you don't like. We already know this is 1 plus I to the number of years, 10 minus 1 divided by I of the corresponding frequency, which is I upper 6. So now we just need to figure out how to compute I6, right? So again, we can do this. This is for 1 year, and on the right-hand side, I use every 2 months to figure this out. Well, you know, by now you should be very comfortable of writing this between any 2 different p's. Right here we have 6 and 4. Right, you can do anything you want. This would give you the result. Of course, you know, there are more than one way to do this. For instance, this is one method, right? I can directly do the computation because I know the size of each payment is 200. Okay, I use my standard S. Right, I just need to find how many payments, the number of payments. I have 10 years. In each year, I have 6 payments. So I just need to find the unit interest rate for every 2 months. So I can do the same thing. This you can calculate from your financial calculator. So this will give you the same result as this. So they are the same thing. So that concludes this section. So let me stop here.